Interference theory states that if y1 equation, the first equation, a sine omega t minus kx1, y2 a sine omega t minus kx2. So here amplitude of the first wave is a, amplitude of second wave is also a. So what is the intensity of the first wave? This is a square into something, and intensity of second wave is also k into a square. This is also k. Otherwise, let me write intensity directly proportional to a square here. Here also intensity directly to a square. As their amplitudes are equal, their intensities are equal. Now, what is the resultant wave produced by the superposition of these two waves? So this is a common. This is sin c plus sin d can be written as from the transformations. Sin c plus d by 2 cos c minus d by 2. Sin c plus d by 2 means omega t minus kx1 plus omega t minus kx2 by 2 cos omega t minus kx1 minus omega t plus kx2 by 2. These two get cancelled. So the resultant wave equation is given by, this is 2 sin c plus d by 2 cos c minus d by 2. So this will become 2a sin 2 omega t by 2 can be written as omega t minus k x1 plus x2 by 2 here cos k x2 minus x1 by 2 here. So from this you can see y can be written as 2a cos k x2 minus x1 by 2 sin omega t minus k x1 plus x2 by 2. Now if you compare this equation with the given equation, so this should be in the form of y is equal some amplitude into sine function. So this is the resultant amplitude of the wave after superimposition. So resultant amplitude is given by a is equal, this is 2a cos k into x2 minus x1 by 2. This is the resultant amplitude here. Now, what is the resultant intensity of the superimposition over this wave? So, intensity is equal to some constant into a square. So, this a square I am going to write. So, squaring of both is equal to 4a square cos square k delta x by 2. But we know that delta phi is equal to k into delta x. In place of k into delta x, you can write delta phi. So intensity is given by 4a square cos square phi by 2 here. So in this case, a square is nothing but intensity of any one of the individual wave. So the resultant intensity of this superimposed wave is given by 4 I naught cos square phi by 2. That is 4 times the intensity of each wave into cos square phi by 2. So this is the resultant intensity. Now, what is the intensity of a wave? Intensity of interference fringes on the screen here. Let us set a screen at a distance point P. What is the intensity? So intensity at any point on the screen is given by, intensity is given by 4 I naught cos square phi by 2. So this is the intensity at any point. If you know the phase difference, by substituting this value, you can find the intensity at that point. Now we know that phi is equal to k delta x 4 I naught cos square phi is k delta x by 2 here. So this can be written as 4 I naught cos square k is equal to 2 pi by lambda. Delta x is the path difference here. If it is y, if it is d and this is a small d, delta x is given by y d by capital D. So this is y small d by capital D divided by 2 here. This 2 get cancelled. So this can be written as 4 I naught cos square. This pi y by capital D lambda by small d here. So this can be written as the intensity at any point. If you know the fringe width here, you can see this is capital D lambda by small d is nothing but fringe width. So this is 4 I naught cos square pi y by beta. Reference due to thin films. Here, light incident at point A and entering into a thin film of thickness T of refractive index n, reflecting from the bottom surface and emerging out of this thin film. But some part of the light will be reflected from the first surface itself. So this is the first reflected surface, this is the second reflective surface here, and it is undergoing refraction here. So if it is angle I, this will be angular, and this is also angular. So what is the path difference between these two light rays emerging? When these two undergo superposition, interference may take place. So to find out this one, first of all, this is the path travelled by the light here, AN, and this is the path travelled by light inside the denser medium, that is AB plus BC. So the path difference between these two is good. Why? Because from this point and this point N and C, these two are travelling parallel to each other. So the path difference is given by delta x is equal to, this is a path of this light ABC, that is ABC minus path AN here. So this is the path difference. So this path is given by AB plus BC of n times, as it is a denser medium, and in rarer medium this is only AN. So this is n into, we know that AB is equal to BC. Why? Because these angles are equal, angle of incidence or angle of reflection. So this is 2AB minus AN. So this is n into 2 into, so how to find AB here? Here we can write, this is AB, thickness of this glass plate is T, so we can write cos R is equal thickness of glass plate by AB hypotenuse. So AB is equal to T by cos R. So T by cos R minus, what is AN here? Once again we have a right angle triangle here. So which we can write sin I is equal opposite side AN by hypotenuse is AC here. But you can see this AC is AM plus MC. So this is AN by AM plus MC. As these angles are equal, these sides must be equal. So we can write sin I is equal AM by 2AM. So AN can be written as 2AM into sin I here. So now in place of AM I am going to write this as 2AM into sin I here. So this is 2NT, this is 2NT by cos R minus, this is 2. What is AM? Once again we have this AM here, so which we can write it as tan R is equal to opposite side AM by hypotenuse BM are equal to T here. So AM can be written as T tan R. AM can be written as thickness T into tan R here into sin I. So now from this we can write N is equal to, we can write sin I by sin R. So in place of sin I you can write N sin R here. So this is 2NT by cos R minus 2T tan R, and sin I can be written as N into sin R here. You can see this is 2NT, this is 2T into N, so you can take 2NT common. So this is 1 by cos R minus, the remaining terms are tan R into sin R. So now the path difference in this case is given by 2NT this is 1 by cos r is nothing but secant r, and this tan r can be written as sin r by cos r here. So if you replace this one tan r with sin r by cos r, sin into sin square r, this is sin square r, 1 by cos r will be secant r. So this delta x can be written as 2nt secant r also common, 1 minus sin square r. So this is 2nt secant r, 1 minus sin square r can be written as cos square r here. So this is 2nt secant r, this is cos r into cos r, but secant r can be written as 1 by cos r here. These two get cancelled. So the path difference in case of a thin film is given by 2nt cos r. Here the path difference we obtained it as 2nt cos r. For reflected rays, here there is no phase difference for this one, as it is bouncing from the denser medium, but it is coming from this, reflecting from this denser medium to rarer medium, so there will be a phase difference of phi here. So now we can write for reflected system as well as for transmitted system. So this is for transmitted system. In reflected system we can write 2nt cos r. Once again we have two types of fringes. For bright fringes, this 2nt cos r must be equal to 2nt cos r is equal 2m minus 1 into lambda by 2, as there is a phase change of pi here. Similarly, for dark fringe, 2nt cos r is equal n lambda. But for transmitted system, as there is no phase change here, so we can use directly the equation, general equations. But for bright fringe, this is n lambda, that is 2nt cos r is equal to n lambda. And for dark fringe, this is 2nt cos r is equal 2n minus 1 into lambda by 2. What type of fringe is formed at O, and if P is a bright fringe, find the value of Y. Remember students, if the slits are placed such that the screen is perpendicular to the line joining the two slits, this is the line joining the two slits, and if you draw a perpendicular line here, this is the perpendicular line, and this line is parallel to the screen here. That means in general, in all the problems that we solved so far, the line joining the two slits is parallel to the screen, but here the line joining the two slits is perpendicular to the screen here. So in this problem, line joining the two slits is perpendicular to the screen, then what type of fringes will be formed at O, and what is the value of Y if P is a bright fringe here. So now in this case, see, if it is the first wave and second wave, the path traveled by these two will be same and the path difference will be 0. Now here at some point, let us say this is the point, the path difference may be 1 lambda. Now for this one, path difference may be 2 lambda. So if we move away from this one, path difference will be lambda, 2 lambda, 3 lambda, 4 lambda and n lambda above the central bright fringe. Similarly, below the central bright fringe also lambda, 2 lambda, 3 lambda, 4 lambda and so on here in this case. But what about this pattern here? Here you can see this is S1, this is S2, this is the screen. Now this is path traveled by the second wave, this is the path traveled by the first wave, and here the distance between these two is given as 2 lambda. So path difference here at this point. Now let us say light is traveling from S1 to O and S2 O. So what is the path difference here? 2 lambda. We know that for first the path difference is equal to that is S1 S2 which is equal to 2 lambda. If path difference is equal to n lambda, we will get a bright fringe there. So which type of fringe is formed at O means a bright fringe will be formed. But in this case, if you take this point, this and this is the path difference here, which is less than 2 lambda. Now, if you move away from this one at this condition, this is the path difference. So slowly, if you move away from this one, the path difference will decrease. Decreases are that is less than 2 lambda. So it cannot be greater than 2 lambda because this is the hypotenuse here, these are the triangles formed here. So as this is the hypotenuse here, the path differences will be less than 2 lambda. That means in this case, if it is 2 lambda, somewhere you will get lambda and here you may get 0 also. After that, you won't get any fringes there. That means number of fringes produced are less here. So the maximum path difference here already given as 2 lambda, and we will get a bright fringe here, first bright fringe, and this is the second bright fringe. Now, here they are asking if P is a bright fringe, what is the value of Y? So first of all, let me take this case. Let us say this is a theta here. So what is the path difference between this wave and this wave? This must be less than 2 lambda. Why? Because as you move up or down, the path difference is always less than 2 lambda. So in this case, at P, the path difference must be less than 2 lambda. So let me take it as lambda here. But how to find the path difference here? This is the path difference. This is delta x. This is a right angle triangle here. So from this triangle we can write cos theta is equal delta x by 2 lambda. So delta x is equal to 2 lambda cos theta. But here I got delta x as lambda. So this is delta x is lambda from our assumption that as you move away from the O, this path difference gradually decreases and less than 2 lambda. So from that basic point we got this lambda, but from the diagram we got this as 2 lambda cos theta. So now equal these two, lambda is equal to 2 lambda cos theta, lambda get cancelled, cos theta is equal to 1 by 2. So theta should be 60 degrees or pi by 3 radians. Now I want to find out the Y value. Here it is given that center of the screen and this is slit are separated by a distance of 10 meter. I need this. So from this I need opposite side and I know the adjacent side. So here I can write tan theta is equal to opposite side y by this adjacent side is 10. So y is equal to 10 tan theta. So y is equal to 10 tan 16, that is root 3. So this is 10 root 3 meters.